Okay, so the time is running. We can start. Good morning, and thank you for choosing my presentation. Okay, there are some people coming, but that's fine. So Die Hard, well, it's cool stuff. We are in the movies because my presentation is a little bit based, like loosely, on the movie Die Hard. Who saw the movie, like the first one? Okay, good, awesome. So you will understand. All right, before I move on, so this is the main character in the movie, John McClane, played by Bruce Willis. And I had to put this slide for the people, well, to do this. All right. Thank you. Okay, so let's start. Now a couple of words about myself. I'm Przemek Bielicki. Oh, sorry, I forgot to change that. I'm in the IT industry for like 20 years. Actually, in June, it will be 20 years since I basically graduated from the university. I worked in different companies and semiconductor, airline booking systems, and currently I'm working at Gradle, and basically my main focus is developer productivity, engineering developer productivity experience. And this presentation is a little bit about developer productivity. So last Christmas, I know that you folks are thinking maybe about summer holidays, but I'm telling you the story that happened last Christmas. And for those who watched the movie Die Hard, you know that, well, this building is a Nakatomi Plaza, in which basically the action took place. There were terrorists, there were police. So yeah. I will tell you what actors we have in this play, in my play. Well, we have myself. So I discovered the terrorists in the building. I relentlessly fought to basically, fight them. There is Vicente Romero. He is Oracle engineer. He is a Java compiler engineer. Well, I would call him the police. So yeah. Now we also have Stefan Wolf. He's my colleague from Gradle, and I can characterize Stefan as FBI. He is a very, very experienced engineer, well, very, very experienced agent who knows, different tricks of other villains. And we have Octavia Togami. She's also my colleague. She also works at Gradle, and she is my superhero in this story. So how it started, basically, what happened? Well, as many cases, it started with some routine check of our main quality gate. I'm working on the velocity. It's a Gradle commercial product. Yeah, I'm not a marketing guy, so I will not tell you more. But if you have access to the presentation, this is the link. You can read more about our product. So what I saw, if you know Gradle, you probably know about cacheability. I will explain it a little bit more. But we saw that the cacheable tasks were not taken from the cache for the same commit ID. That was like, what's going on? Something's wrong. And the build performance was obviously visibly degraded. So don't panic, don't run away. You don't have to. I know that this can be overwhelming. The only thing that I want you to focus on now is this red thingy. We see the SHA of some task of the scan server jar task. That's the only thing I would like you to focus on this slide. I will come back to it. The thing is, the expectation is that the SHA resulting cache key is exactly the same it isn't. And then later I will explain what's happening here. So a little bit of theory, just a couple of slides of build caching, because maybe not everyone is aware of what it is. So build caching, it's a technology introduced to the Java world by Gradle in around 2017, used by leading technology companies. And what is important that it can support both local users and CI systems. Important thing is that some people sometimes confuse build cache with the dependency cache. They are complementary, not exclusive. Then build cache accelerates building a single source repository. So if you have like a big monorepo, that's something that will help you a lot. And the build cache, Gradle build cache focus on like little increments on build actions, like Gradle tasks or Maven goals, right? So by the way, now, well, build cache was introduced to Gradle, but now it's also available for Maven and other build tools. So how it works, obviously we have some inputs to Gradle task or to Maven goal execution, and we have outputs, right, out of those tasks. What is important? That might be obvious, but it's not necessarily the case in reality. When the outputs have not changed, the outputs can be reused from previous run. So Gradle as a build tool is awesome in basically avoiding doing things. It's lazy. Why should I do stuff that was already done? Now, a simple example, how the cache key and the cache value are computed. Let's take an example of the Java compile task. So the cache key is basically the hash of source files, JDK version, class path, compiler args, right? And the cache entry contains basically the compiled classes. That's it, as simple as this. More information, documentation, obviously. So we have remote build cache, right? Remote build cache is writable only by the CI system, not to poison it by local developers, but it can be read. Well, it speeds up local development cycles as well as the CI. All right, that's the end of theory. So let's dive deeper into our problem using the velocity. Now, okay, again, I know it's a lot of information, but I will just point what are the important things. Well, I said same time, it's almost the same time, but it's like, it's 10:05, 10:04, couple of seconds difference. So basically those two builds, what we see basically on this slide is a comparison of two different builds running in parallel. So important thing here, same commit, exactly same commit. This changes, this differences, basically they are running on different machines. So obviously we see those differences, but they are not important in this case. And here I point single reasonable difference. But hey, take a look. We have a difference in the operating system by one patch. It's the Linux kernel version. 166 generic, 167. Yeah, I checked that. Doesn't seem impactful. So there are a couple of files that were changed. Yeah, so it looks okay. Now, the next tab, well, infrastructure. Well, obviously, we see again the difference in the kernel version. Well, we have different memory settings that generally shouldn't play a difference. It's not an input to the task. And of course, we have different agents, CI agents. We also have on the screen a tag. Okay, those builds will run. Well, we don't see the other build because that would be unreadable. We see that it's run in CI. Yeah, the date, well, today because it was run in December, and I made the screenshot the same day. Feature branch, it's run on Linux, and this is the branch on which it's running. We also have the Gradle version, the Gradle Enterprise plugin, etc., etc. So we're coming back to this slide. Now, what we see, I'm comparing the task scan server jar. And what we can see is that for the same commit ID, we have different output, different cache key. And we see exactly in the velocity gives us information why. What is different between those two builds? And it says we have a difference in those two classes, Gradle execgraph, not execution info class, and Gradle execgraph, right? So my first thought was, okay, maybe those classes are basically generated and there is some randomness. Not at all. This is like the fixed source code. Let's move on. Now, Stefan Wolf, the FBI agent, came and says, hey, you know what? It looks like the manifestation of the non-deterministic behavior of the Java compiler. And now you should say, what? And he said, yeah, it happened before. Right. What would happen if I told you that I made this picture like in Gdynia a week ago? You probably wouldn't believe me. Yeah, but it could be possible. But that was basically my reaction, right, to this, like, what's happening? Here are the consequences of this, let's call it misbehavior, because at the moment we were not sure what it is. So this file that is different in those two different builds is the core of the Velocity server side. Okay, but so what? Well, it's being used, it's being built and then used by thousands of tests, because we have thousands of tests that basically check if it does what it should do, if the performance is correct, if the functionality is correct. Okay, but so what? Well, different SHA means that all of the depending tasks, for example, tests, but not only, are being re-executed, okay? Not taken from the cache. It's a massive waste of time and money, like massive, because the build, instead of taking like 4 minutes, 3 minutes, it takes 40. That's the difference because of that. And of course, developer productivity suffers. Why? Because developers have to wait instead of 3 minutes, 40 minutes. That's bad. Okay, as I showed you, this is observable using the velocity. Okay, at the moment, so Stefan suggested, hey, this might be a bug in the Java compiler. It's just a hypothesis. We had no proof, nothing. So, you know, I showed you that those two classes were different. One of them was Gradle execgraph node execution info. And what's so special about this class? It's a public sealed interface, and it has 2 or multiple records implementing it, right? We have record 1, record 2, we could have more. It doesn't really matter. It could be 5, and the number doesn't matter. But what matters is that we have more than one. So the records in Java were added in Java 14, and sealed interfaces in Java 15. At the moment where I discovered this misbehavior, our build was running on Java 17, but Java 21 was already there. So basically Java 15, correct me if I'm wrong, but it's like at least 5 years ago. And I said to myself, no, it's not possible that I discovered the bug in the Java compiler after 5 years. It's basically, you know, I'm being crazy. It's not possible. Wake up call for you another tool because I want to explain something. So I don't know if you're aware of the Java P tool. Java P tool is a simple tool that is part of GDK. It decompiles the bytecode and shows how compiled classes look from the JVM perspective. That's an important thing, from the JVM perspective. I need to explain some options because I will use them. So -C basically prints the disassembled code, how it looks from the JVM perspective, prints lines and local variables, and private shows all classes and the members. Basically, we want to show everything of the class. There we go. So we are comparing the class that was compiled on this machine and the class that was compiled on that machine, right? So what it shows? No difference. It's the same. Okay. I don't get it. But it's not. Here, the only single difference is there are 2 bytes that are basically switched. Okay. But if I go back, they are the same. Okay. Anyway. So when I also compared the jars in IDEA, so that was a little bit funny and weird. IDEA showed something like that. Okay, there is a difference in those 2 files because the SHA is different, but there is no difference inside. It looked like that. Yeah. So that was me at this moment. And I remember that my team lead was actually living on holidays, Christmas holidays. I was staying at work for 1 more week, and I was feeling like John McClane, and saying, I don't know what to do. I'm blocked. I'm screwed. But I knew that there is an issue somewhere underneath, but what it is. Okay. So crawling through the ducts began. Okay, what could I do? I could just report it back to GDK. Well, I've just got the link, not to pollute, but you can check. There's public discussion, what actually happened, the whole analysis. There were some emails that I interchanged with Vicente privately, but most of the discussion is public. The thing is that I discovered what's happening. Well, I described what's happening, but it still wasn't a bug. It wasn't a bug report. Yeah, the issue was created as usual with all the information provided, but still we were not sure. And here are some famous quotes. It's me, the expert of the Java compilation. So my expectation is the compiler must produce deterministic output of the compiled classes, at least when the GDK version is the same. Makes sense, right? I'm not the only one who thinks that. So when you go to the page reproduciblebuilds.org and read about JVM, what they say or what they claim, Java compiler generates reproducible bytecode class output. And they write some more information about that. Okay, makes sense. What's the reality? It's the quote from Java compiler engineer. Yes, having deterministic output is a very desirable property of a compiler, but not a guarantee. And he's right. So Java compiler is mostly deterministic. It is very deterministic, but it's not a guarantee. If you are working in Groovy, it's, well, what word can I, well, it's worse, because Groovy compiler is extremely non-deterministic. So you could have a different output even on your machine when you recompile stuff. So at this moment, we didn't have one hypothesis, we had multiple hypotheses. My favorite was Java compiler bug, but no proof. We were also thinking that maybe Gradle incremental compilation plays the role here, because we heavily use it in our build. Now, we also use heavily annotation processors. So they annotate classes, they modify the bytecode, right? But that was all, it's a complex build system, so like proving any of this is difficult. So what happens, that's once again just a screenshot of the screenshot. Let's focus on this class. Because what I did before, but of course now I'm smart, because I know what happened. But at the time, I didn't know where to look for deeper. Okay, so now, okay, I just extracted this particular class from both nodes, machines, and here is what I found. Let me just move back. So what we see here is that in the public sealed interface, the permits, so basically the records that were declared are in different order. Okay? Here we have task first and then transform. Here we have transform first and then task. Oh, does this ring the bell to you? Is it maybe this switch of the bytes order in the decompiled class? I was at this moment, I was sure, okay, I send this information to the Java compiler engineers. They will know what it means, right? They know every byte. No, they don't. But we had a lead. We had a lead, and that was good. Okay. So what did we do at that point? I exchanged multiple emails with Vicente, like how we can debug the problem, basically get to the bottom of it. So Vicente built different custom JDKs for me, and what was special about those JDKs is that he basically added some more logging to the compilation process. Of course, Vicente was working on the main branch. That means that it was Java 23, and our build was running on Java 17. Yet another issue to solve. It's not that easy, right, to quickly switch from Java 17 to 23. That's okay. So we confirmed the hypothesis. Well, we confirmed some of the part of the hypothesis using extra logging. We understood that indeed the output of the compiler is biased by the order of those records. So that's how the output of the Java compilation looked like, right? So in the log where the compiler actually was compiling this class, it basically printed some extra information, right? What is the permitted list at the moment, at the first and the second? And it turned out that indeed on those two CI nodes, the order was different. But why? And here's just again, something that is observable using the velocity. As you can see, the Java tool chain, yeah, I found it funny. It's like internal, ad hoc, and Vicente Romero Git. Okay. So we have the fix. The fix is ready, but The problem is still not understood. So can you imagine this? We have the fix for the problem, but nobody understands the problem. So here's the pull request. I don't want to dig into the code, but the fix is quite simple. It's reordering and reshuffling classes, and it ensures that the classes are compiled in the right order. Okay? But Vicente created this pull request and said, okay, I know here is something that can solve your problem, but I don't know if this is the root cause. So here is another famous quote. I like it a lot. I think this is you won't find it publicly. It's the private message that he sent to me, but don't worry, don't panic. I have his agreement. I can share it. So I will read it. That means that the sources were not reshuffled. So this is still a very weird issue in the area of impossible, in the sense that I still can't understand why it's happening. This is the quote from the Java compiler engineer. He's a good engineer. It's not his fault he doesn't understand the issue, because the issue is basically tricky. And here is my superhero to the rescue. So again, we had this lead. This is a Java compilation bug, but maybe another lead, very important, that I showed before, was incremental compilation of Gradle. Because Gradle, again, is a little bit lazy, doesn't recompile all the classes, but tries to recompile only the classes that were changed, right? And then incrementally adds work. And that sounded like it could play a role, because every time the order of classes that are added for the compiler to be compiled can be different. So I reached out to the Gradle internal team in charge of the JVM world, in charge of integration between Gradle and the Java compiler. So Octavia, przepraszam. I'm sorry, I made a mistake in the presentation. It's not Olivia, but Octavia. Confirmed that Gradle incremental compilation has no influence on the resulting bytecode. Now, what she did in 24 hours, she created the minimal reproducer. That was like, yay, awesome. And she confirmed that it is, should be maybe bold, it is a Java compiler bug. That was awesome. Let me explain the reproducible a little bit. Here is the link. You can check it. Well, even the link is complete. It's great. When you compile Java classes, of course, you have Java C, and then you pass the files that you want to compile. And here is how you can reproduce the issue. In one of those classes, we use this public sealed interface with the records, right? So if you switch the order, then it will be like always the same. Then the resulting output will be the same. But if you have this order, the output will be different, which means that Java compiler is like biased or influenced by the order of input files, and it shouldn't. Okay, I think I'm going to finish before. Here is the good news. This bug is now fixed. Yes, that's great. And, well, that's almost a good news. It will be integrated in JDK 2104 So it's not available yet. We are still in the velocity, we are still hitting this issue from time to time. That's really annoying. Okay, so bye-bye to the bug. It's done, it's fixed. So finally, I can say Yippee-Ki-Yay, motherfucker, to the bug. So I was really relieved. And well, it took me less time than I thought. So I'm done basically. That's all I got for you. Maybe almost, because I wanted to give some special thanks at the end of the presentation. So I wanted to thank Kevin Davin and Oliver White. So Kevin and Oliver, they helped me simply with writing the abstract for the presentation. They motivated me to actually do it, because I'm really out of my comfort zone here, especially in this outfit. That's even more out of my comfort zone. And actually, yeah, that was Kevin's idea, so to wear this. And I also want to thank Piotr Zieleziński, who actually is from here, from Krakow, for test driving the presentation, and he also gave me like the feedback, what could be improved. Yeah, that's it. Thank you.